And we have the next presentation, Stefan Bertsch. Professor Dr. Stefan Bertsch is actually my boss, or our boss, from Fred and me. He has a PhD from Purdue University from the US in 2008. He also was appointed as a full professor at NTB, so at the university here in Bux, the University of Applied Sciences, and which is now called OST, Eastern Switzerland University of Applied Science. And since then, he has served as the head of Institute for Energy Systems, now over 16 years. In 2020, he was appointed as head of the Department for Systems Engineering. So we have published quite some papers also together, and he has done several contributions, national and international talks and presentations and events. So he's pushing heat pumps into the field. Okay, Stefan, the floor is yours.
Thanks a lot, Cordin. My topic is not as technical as the ones we had before. So I want to go one or two steps back. Why do we need heat pumps? Why do we need an electrification? I think Guido Sutter already showed it quite nicely, that in most processes you need heating and cooling. The product goes in at the same temperature, where heat pumps are one of the best possible solutions. So in Switzerland, I'm taking the Swiss perspective today. Many of these points can probably be also stand for other countries as well. In Switzerland, industry is only about 20% of the total energy consumption. That's fairly small, actually, to an industrialized country. And 2/3 of that energy that is used is actually heat. It's process heat, it's space heating, it's domestic hot water, and so on. And 80% of that is produced from fossil fuels. So that's the state of the art at the moment. And heat pumps are one of the natural solutions we can use to get there. In Switzerland, at the moment, we see a huge decarbonization using biomass. So almost every larger company that needs heat is starting to go into biomass, which we think is actually not the optimal way, because, for example, the sustainable potential of biomass heat would be 71 petajoules, whereas the heat demand in industry is about 82 petajoules. So we couldn't even fulfill the demand with all the wood we can plant sustainable. And wood also has a lot of other functions. Wood is a seasonal storage. Wood is an important raw material, especially if you look at the plastics industry, in case there would be no oil at one point. So then the only other good solution is actually the electrification. And you can go for direct electricity. So from 1 kilowatt hours, you get about 1 kilowatt hours in heat. You can use synthetic fuels. One topic we hear a lot, you can go into hydrogen, methane, and so on. The problem there at the moment is the efficiency, the conversion efficiency to heat is only about 50 to 70%. The higher processed it is, the lower. Or you can go with the heat pump. So if you look at the heat pump, for example, in comparison to synthetic fuels, you have a factor of 4 to 8 less energy need. So at the moment, we are not in an area where we have an abundance of renewable energy. Therefore, wherever we can, we really need to go for heat pumps. In the long term, if you need additional storage and so on, synthetic fuels might be a very nice option. But right now, as the energy system is in Europe or in most countries, heat pumps are really a necessity. So where do we stand with respect to market adoption? High temperature heat pumps are really new to the market. We are not even in the early adopter phase, we are in the pilot demonstration phase. So there's still a big way ahead of us. If we compare that to residential heat pumps, in Switzerland we are at about 65%, almost 90% of the new buildings are equipped with heat pumps. That's a complete different stage. So we ask ourselves a lot, how can we actually challenge industry? How can we challenge also our government to implement heat pumps faster? And so that's one of the topics or major topic I'm going to talk about at the moment. So I really like what I see today. when we look back 2018, that's not long ago, Cordin actually did an overview of what kind of high temperature heat pumps do we see at that point. If you look into 2024, we have a complete different temperature range we can achieve. We have very big capacity heat pumps. We see more and more heat pumps using natural refrigerants. So we really can see that the market is growing. Very, very good news. And we also see that industry actually has the intention of implementing them. Still, we usually get the question, so where can I look at the system? Where can I see one running? And the answer is still very often, well, that's not that easy. So it's really how do we get the market started? We also try to optimize implementation of heat pump systems. So there is different ways you can integrate a heat pump directly into a process, into a machine. So for example, if you're producing cheese, you on one hand need to heat it up, on the other side you can cool it down. You could make a machine that has a heat pump integrated. The advantage, you very often have simultaneous heating and cooling. You're less dependent on the grid. You only need electrical power going into the system. You have less waste heat. It's very easy to actually grab the heat also. So that's one idea. Usually it's a different way. At the moment we have one power plant in a factory that produces steam or high temperature heat with a gas boiler or other fossil fuel boiler, and people try to replace just that steam boiler, which in many cases is also not the optimal solution. So there's different ways of integrating, and what's important in my eyes is not just to replace a boiler, but to figure out what is the correct temperature. How should we implement the system? Because the larger the system boundary is, the more you could actually get the better potential. You can reuse heat from one process in another process. For example, directly you can install heat pumps in different areas, but at the same time, the complexity gets bigger and bigger. And when we go into plants, seeing how a system should be integrated, then usually the major problem is most manufacturers don't actually know what powers do they need for a certain machine, what temperature does that machine use. So they very often try to go the easy way and just try to replace steam in one go. We can see different examples. We have companies that are actively reducing temperatures. They have a gas boiler at the moment, and they're reducing steam pressure to see at what temperature would the process start to fail. And that's one approach to figure out where is the limit, how low can we go, because many processes need quite low temperature. So for decarbonization, it's really important to collect the energy data. So whenever there is a change in a system, let's install power meters, measure the flow rates, measure the temperatures. They will really help to bring a much better system later on. Even so it costs in the beginning, you will save in the long term. Energy analysis is very important. Sometimes one of the case studies we heard was not industry, it was a hospital that actually has a centralized heating system and needs steam. It's very easy to see what temperatures and what powers at what temperature level, but in most companies it's much more complex. So from the energy analysis, it should go into concept development. Then comes implementation, monitoring, and optimization. What we have seen so far, the data extraction, to really get some data of what the processes need, is about 60 to 70% of the effort if you're into designing a new system. The energy analysis and coming up with a concept is actually fairly little in effort compared to how to get to the data. And in Switzerland, there is actually funding to do this energy analysis, but not in other countries. And so since this first part is actually very big topic, there is also research going on into how can we actually get this data much better. And for example, what we can see here, these are the temperature curves, temperature enthalpy curves of different processes, all anonymized, of approximately 200 different plants in Switzerland. And what we can see is that most temperatures on the hot side are in the area of 50 degrees, 90 degrees, 100 degrees. There's actually very few processes going up to 200, 250 degrees. So if you supply at 200, for example, the red curve, it would have been much better to have a heat pump supplying at 80 degrees. And then you have already 80% of the heat at a very high efficiency. And then for the last 20%, you can look at either into a very high temperature heat pump or sometimes even into electrical heating if, like here, it's this little energy. So what we try to do is, or we in the project Decenal, we are part of it, besides University of Geneva and University of Lucerne, is to collect data to make representative curves that in the future you can go ahead and say, I'm in a cheese factory, they produce this many tons of this kind of cheese, this many tons of yogurt, and from there on you can deduct what temperatures they actually need at what power. And this could help us to design much, much better systems. We see several industrial plants that go away from having one hot supply and one cold supply, which is very nice in upkeep and cost, to grids that have 3, 4, or even 5 temperature levels. And with that, the overall efficiency can be much, much higher. So where do we stand with high temperature heat pumps? We've seen already several today. We can go up to 200 degrees with some of the technologies. I'm not going into detail there. There's many other talks on that today. But one of the topics that was also very interesting to us, which are the most sensitive cost parameters? And we can see here the largest impact is really the fuel to electricity price ratio. If we have countries that have very cheap electricity, then heat pumps are much more easy to be sold from the beginning. If not, then it's much more difficult. Overall, I think electricity prices will come down. We've heard that also before, because all renewables energies will supply at very low prices. So long term, I'm quite sure that actually the cost ratio for electricity will go down. Then second biggest factor is annual operating time, and then temperature lift. So fuel price, temperature lift, and operating time are the biggest factors actually in how to get a good return on invest. So what do we need from a technical point? We've heard it already today. Steam compressors, everybody is yelling for small scale, medium scale steam compressors. So that's definitely a topic. We need also combined solutions, including storage. So far, it's relatively new systems. So very often it's a heat pump, very often still with a backup heat source, optimized control. What we also need is data from successful installations to show how things are going. So we're trying to collect, make them public in anonymous ways to really help the acceleration of implementation. And what would also help is standardized systems, also standardized testing to have a better comparison. I know still quite a bit out. What we also need, and I think as urgent, is really from policy side. We need de-risking of pilot installations. I mentioned before, many companies ask, so where can I see a unit? Where is something running? We need to demonstrate that it works. And there is sometimes grants, sometimes credit lines without interest could be an option. So not even that expensive for a government, but that's one thing we really need. We also need very clear energy regulations. We can see it with the electric car market, how the uncertainty of is it going to be electric or not is actually really hindering the market. Same thing here. The more stable regulations are, the easier it will be to adapt to them. And we also need education, training, and open data. That's what I already said. We like to collect and publish the data. We like to collect and bring databases of what products are on the market, where has someone installed a pilot, to have some easy assessment tools to really get into contact and start talking also to the customers. So the IAA HPT project 58 was especially on the different producers of high temperature heat pumps. I don't know why they're all vertically aligned among each other, but it seems like this is a very good stretch to produce high temperature heat pumps. And also starts collecting more and more pilot plants and installations. There is also now a database out there. If you're interested on bringing your product onto that database, you can contact us. It's collaboration between Germany and Switzerland also to really help bring different products closer to the customers. The links are here. They will be online later on as well. What else? We also did several studies in Switzerland on what are the key factors why someone does not implement a high temperature heat pumps. For example, many of the replies were energy cost is so low, it really doesn't matter. It's below 1% of our turnover, so we don't care about it. We are producing X, Y, and Z. We are not energy people. Another problem is that there is not enough information, and I think we all can battle that together by combining the information, putting it on platforms, and bringing it forward. So here, two different calculators. They're very simple payback calculators. One is an online version with different countries. The Excel sheet here allows you to adapt more by yourself to easily do a calculation. How much would the energy price be given a certain heat pump, given a certain application, certain temperatures, to show a little bit of a comparison very quick to, for example, fossil fuel systems. So if I would be a heat pump manufacturer, where should I go at the moment to install heat pumps? I probably would go to Sweden because gas and electricity has almost the same cost. So you need a COP of 1.1 to be competitive already. And that means reversed, if you have about 50% Carnot efficiency, you could do a temperature lift of 200 degrees. Quite nonsensical as a solution, but still it shows us which countries are there that will see really a surge in high temperature heat pumps. Which countries, for example, if we see here Slovakia with a ratio of 4 between gas and electricity, you need a COP already of 3.7 in order to be competitive from a market price. So this could also probably help a little bit to figure out which countries can be within the early adopters. And last but not least, it's not just about the technology, cost, and implementation. It's also about, are there different business models? Since we had the feedback of heat pump, or we are not energy providers, it's not our business to invest too much thinking. We can burn something, but we are not really into, we cannot handle the complexity of a heat pump, for example. So there is different models also. I mean, it can go into contracting or leasing or heat as a service. If you go a little bit further, even energy as a service, then you can have combined heating, cooling, and power, for example, and not just the heat pump. So I think there's also quite a bit of area for new business models and proposals to really push the new technology. For those interested, Fred already mentioned it in the introduction. We do have also a 4-day training course. The next one is in English, actually. Here are the dates. If anyone is interested, the first 2 days are online and on campus here. Day 3 and 4, we cannot do online. It's really practical training in the lab, and looking at 5 different installed high temperature and industrial heat pumps in Switzerland to really see how they work and get some real life experience. And for the German-speaking population, I'm sorry, this is only in German, there will be actually a forum at our campus in March where we try to bring together heat pump manufacturers, bring together also customers, planners, to really facilitate matchmaking between the different stakeholders, with short pitches, but mostly also time to discuss, time to bring in your own projects and find potential solutions there. So only in German and only here on campus. There is no online version. So summarizing my talk, we need a lot better knowledge transfer. We really need to share information. I know we have competitors in here, but I think if we can go ahead and work with anonymized data to really show and ascertain that the topic is of interest and the heat pumps work, that could help all of us. Standardization would definitely help for certain applications. For example, there's a 3-bar application that's more or less similar applications, including storage and so on, to really make it less of a challenge for installation, and really come up with guidelines and train the qualified personnel. And I'm also especially talking about planners here, about energy consultants, since many of them still are used to the fossil age and therefore don't have the knowledge they need. So that's a few things we are trying to do. We're really happy also to share our knowledge in case there is any questions about that, and more information on our website or on Sweet Tea CH, who is funding the dissemination of all of this. So thanks a lot.
Super, very good presentation, Stefan. Very clear, like usual, like always. So
he wants a raise, I guess. So
you showed